Hello everyone, I welcome you for ACD narrative classes. I hope all is well. So in the regular classes already we completed the 5 experiments out of 7. In the last session we discussed about the LALR bottom-up parser by using add tool. So in this session I am going to be discuss the shift reduce parser. So shift reduce parser. So all you know about the shift reduce parser. It is a one type of bottom-up parser. It has the one stack, input string, and our action. Okay, the stack initially it begin with the dollar symbol, and input string is beginned with the string or word append with the dollar. And initially there is an action, but the first action always shift. So at the end or finally, when we are talking about the bottom up parser, the stack must be dollar and start symbol, and the input string have only dollar. Then only we are saying accept. Otherwise, we are saying reject. Okay, this is the basic conditions for the shift reduce parser. Initial stage, under stack we have the only dollar, input string we have the input string and r word append with the dollar, and initially there is an action. But whenever we want to implement the action part within the shift reduce parser, we must be first apply the shift operation only. At the end, finally, the stack consists of dollar followed by the start symbol, and input string consists of only dollar. Then it is the accept. Otherwise, it must be the reject. Okay. So now I am considering the global variables for my program to hold the input string by one variable input string. It is a one-dimensional character array, and to hold the stack content I am using the one-dimensional array stack. It is also the character type, and we know each and every parser is going to be verified only one input symbol at one instance of time. So for that purpose I am using the one indexing variable to pointing the current input symbol. So we know the basic rule, always our indexing variable type must be the integer. Okay, good. And my variable name is input pointer ip underscore ptr, nothing but input pointer. In the same way, when I am talking about the stack, I am not taking the action for all the symbols available in stack. We are taking the action first top of the stack. If it is not possible, top of the stack and below the top of the stack, until we are saying in the downwards. So to pointing the top of the stack, I am using the one indexing variable TOS. It is also the type integer, and also I am using the one integer variable that is giving the input string length, and one is for the general purpose of indexing, and I need the two strings for the temporary purpose. Whenever I want to be apply the shift operation, I want to be specify particularly what is the symbols I am going to be shifted. That symbols holding we must be required for holding up such type of symbols. We must be required certain variable. Here I am using the variable temp underscore ip underscore str, nothing but temporary input string holding array. And whenever you are taking the action with respect of reduce, that reduce must be taken from the stack only, so it is our stack. And the stack also we are not considering all the symbols at once, we are considering some limited set of symbols. So what is the set of symbols we are considering for reducing? That set of symbols we must be stored at one variable. For that purpose we are using the temporary stack. Okay, and to print the action, whether it is accept, reject, shift, reduce, for that I am using the one more array ACD, nothing but the action. So these are all the variables for us in my in our program. IP underscore str, nothing but to hold the input string, stack to hold the stack content, IPPTR, nothing but to hold the input pointer current position, to is nothing but top of the stack, len length of the given input string, I for the indexing purpose, and temp underscore ip underscore str, it is a one array. Whenever I am shifting the symbols, I am not shifting all the input symbols at once. How many input symbols I am shifted at that instance, I want to be store those symbols at one place with the help of one variable. For that purpose I am using the variable temp underscore ip underscore str. Okay, and also in the same way, whenever we want to be take the action reduce, it is not possible always all the symbols in the stack. We are using sometimes very limited some set of symbols which are available under stack. So which symbols we are using now to take the reducing action? Those symbols are once again stored with the help of one variable. That variable I am using as the temp underscore stack. And also which action I am writing, nothing but either shift or reduce. For that purpose I am using the one array ACD. Okay, now observe, I am using the one function check. Now I am talking about the main function. So this is my display message, and I am considering the grammar for the shift reduce parser is e gives e plus e or e gives e star e or e gives e by e or e gives a or e gives b. This is our grammar. Okay, how many productions we have? We have the 1 2 3 4 and 5. My dear, be careful, it is the by, not the or. E by e, it is a e plus e, it is a star e, it is the a or b. 5 productions we have, so I am displaying those productions. And also I am asking enter the input string. So for that input string we are storing under ip underscore str and the stack implementation table. And how many columns we want to be represent? Stack, good. Then input string, content, nothing but input symbols, and the last one action, good. So for the visualization good visualization, I am using the two tabs for the each and every column space. Stack, two tabs, then input symbol, two tabs, then action. Okay. Initially I am going to be print the content. What is the initial case? Our initial stack consists of only dollar, good, and in our input string we are going to print the entire word, entire input string appended with the dollar. So that's why percentage yes, where instead of percentage yes we are going to print the IPSTR, where IPSTR is given by the input string. Good. Okay. And initially there is no action, that's why I am representing two dash symbols. I hope all you are following me. Until now it is not an issue. It is the display message and it is the initial display content. Okay. So now observe which action first we are going to be choosing. Shift. Good. So that's why under my action string I am going to be write the string shift. So I am copying it, and while we are implementing the programs by using the strings, be careful, the string must be uh, ends with proper string null character or not. So for that purpose, what is the action I am transferred into the act? Nothing but the action. The next character I am going to be considered as the null character. Okay. Shift, which thing I am going to be shifted? First symbol. So that's why uh, my input string entire input symbols is held by the IP underscore str. In that first input symbol, nothing but first my current input pointer is the first symbol. So that's why initially I am setting my current input pointer value is the 0. So input string of the 0 I am pass it to the temporary shifting purpose holding variable is the temp underscore IP underscore str. Good. So temp underscore IP underscore str of 0 I am transferring that symbol, and when you are implementing the programs in C by using strings, you must be close or end that string with null character, otherwise it may be use the garbage values. So that's why I'm interested to append the string with a null character. Previous character is 0th index, null character is 1 index. That is the thing I am going to be shifted. Okay. So what is my previous ACT part? Shift. Now I am going to be append with my shifting symbols. My shifting symbols is where I am storing my shifting symbols, temp underscore IPSTR. So this part I am concatenate with my previous action part, nothing but ACT. So now observe how many times we are going to be repeat this loop until all the input symbols we verified. So how many input symbols we pass it for our input string, how we know? So we know our input string variable. So whenever you want to find that input string length, uh, so if your length is n number of times we are repeating it. So simply I am finding the string length with the variable len. Already we discussed that purpose of len variable, and my indexing initializer with a 0 and less than my length. Here if you are writing less than or equal to length minus 1, otherwise simple you can write less than length. That is a simple. I equal to 0, I less than length, I plus plus. Okay. And when you are shifting it, what about your stack? Initially you have the dollar. Okay, good. Now this is your top of the stack. Your top of the stack is filled with present input symbol. Present input symbol is given by the input pointer, nothing but input string of input pointer. And also I am considering it is the one string. So that's why my top of the stack can be increased by 1 and that must be appended with a null character. And when that input symbol can be shifted to the stack, which input symbol is shifted from input string to the stack area, nothing but this is your stack and this is your input string. If the symbol A can be shifted into the stack, in the next time when you are going to print the input string part, A is not interested to print it. So for that purpose, I am using input string of input pointer. What is the input symbol I am considering as current input pointer character? I am going to be removing it. Consider as a white space. Okay. After that, my input pointer can be incremented by 1, and I am going to print the entire thing. So dollar followed my stack content, input string followed by the dollar and the action part. Okay. So now when I am doing the first shift operation, I want to be check it whether that shift is possible or not, or that reduce is possible or not. So for that purpose I am writing the one function, that is the check. So this is my check function. So here I am using the one flag variable. If the flag variable initialized with a 0, if it is turned with the 1, that means what is the input string I am passing, that is accepted. Nothing but either shift operation performed or reduce action performed. If the flag does not turn into the 1, or what is my initial flag is there, that indicates it is an error. Okay, be carefully. The flag is not turned, then it is an error. If turned, it is error. Nothing but accept. So observe it. Temp stack in the sense stack which symbols we are considering for the reducing step. Now observe, if my when I am talking about the stack, okay, so it is a 0. Initially we have the dollar, it is a 0th index, nothing but our input symbol, and 1 index null character. I am verifying 0th indexing position character, not the null character. That's why stack of, it is our stack. So stack of 0, either A or B. If it is A or B, then only we are reducing into the E. When we are reducing into the E, you must be right, or the stack content input string pointer and reducing. Reducing in the sense simply I am using E gives what is the symbol I am going to be reduce, the entire, nothing but my first symbol append with a null character, that is the reducing. When I am reducing, that reduced step is accepted here. Reduced step is accepted by dear. Don't get the confused here. Reduced step is legal. Accepted in the sense don't assuming the entire input string is accepted. Here I am considering the only one symbol. Instead of that symbol, I am not concluding the entire input string is accepted by Shift Reduce Parser. But what is the reduce step we applied? That is the legal, nothing but the valid. For that purpose, when it is the valid, my flag can be set as turned. If it is not turned, then reduce is not possible. That is the meaning of it. Okay, and now observe. When you are the stack compared with the entire string, what are the possibilities with respect of terminals according to our grammar? It may be the A or B or plus or star or by. Okay. So I am going to be compared it. String comparison of my temporary stack, which symbols I am considering from the stack, that is the A string or B string or plus string or star string or by string. So be careful, don't write A within single quote. If you are writing A within single quote, if your string is A followed by null character, it is not the same as A. The reason is it is a string and it is the character. When these two are the same, A append with a null character, if it is a string, it must be the equal if and only if when A is the string. Okay, be careful. In the same way, B in the same way, plus star and bar. And you know, when the string comparison, nothing but both strings are the same, what is the result we are getting? 0. Good. If it is 0, nothing but if, when you are writing the if it is 0, that means we are talking about the false. So to avoid it, when the two symbols are same, I am in the success mode. Nothing but the legal operation is, or it is a valid action. So that's why I am using 0 complement, nothing but not. If not string comparison, if not string comparison, not. Okay. When the temporary stack is same as the A or B or the plus or star or by, I am performing the legal reduce operation and I want to be set the flag value is 1. In the same way, when I am verifying the entire stack content, nothing but the string stack, entire stack, that may be the my production alternatives, either E plus E string or E by E string or E star E string. In the same way, when the strings are the same, it returns the 0. When the strings are the same, it is a valid. That's why I'm using the not string comparison. Okay. And when I am writing the reducing, particularly I must be say either E can be reduced into E plus C or E plus E can be reduced as E, or E star E can be reduced as E, or E by E can be reduced as E. I must be specified for that purpose. When these three conditions are met, any one is met. First I am going to be verify either first one met or second one met. If first one and second one not met by default, third one met. Have you got my point? Clearly observe here. I am going to be compared the entire stack content. Nothing but maybe your top of the stack is the E, then below one is the plus, and below one is the E, and last one we have the dollar. So I am not considering the dollar in my stack. That's why my implementation. But that's why whenever I want to print the stack content, dollar append with the stack. So that's why my stack is compared with the E plus E string, or my stack can be compared with the E star E string, or my stack can be compared with the A by E. When these two strings are the same, we are getting the 0, not 0 in the sense true. When it is a true, I am verifying which thing is. Either it is the E plus E. If it is the E plus E, E plus E can be reduced with E. If it is the E by E, E by E can be reduced with nothing but when we have the three conditions true, I am going to be verifying individually either first condition or second condition. If these two conditions are not, automatically it must be the third condition, not required to once again verify here. Here either condition 1 or condition 2 or condition 3. When these three, any one of these three conditions met, then only we are enter into this part. So here I am verifying the condition 1 or condition 2, not required to verify the condition 3 once again. The reason is when these three are true, either it must be belongs to condition 1 or condition 2 or condition 3. We have no right to get the fourth condition or except these three. So that's why I am not verifying once again for the third condition. Simply I am considering when the first two are not, automatically it must be the third condition. So else I'm verifying. Directly E star E can be reduced with a E. And clearly observe, when I am taking the action with respect of reducing, my flag value is 1. And also, if you are clearly observe, the entire stack content I reduce. When I am reducing entire stack content, I don't know whether my input symbols are all verified or not. Maybe some more input symbols are there to be verified now. For that purpose, I must be set my top of the stack pointer or indexing once again for the initial case nothing but the 0. If I am not setting, the remaining symbols are going to be add for from above that. Nothing but the below symbols are also valid. It is not the legal. For that purpose, I must be set my top of the stack value once again 0. Okay, and my stack finally my stack having the only E and all the input symbols are verified. My current inputs symbols verified is given by the input pointer. If you are considering your input length is 3 A plus B, your input pointer initially is input pointer initially is value 0. When it matches, it increment nothing but initially it is 0, then 1, then 2. When it matches, it increases 3. What is your string length? A plus B string length is 3. Now observe, our input pointer value is 3 and our string length is also 3. Which variable is given by our string length? LEN. And our input pointer value is also 3. So that's why I am verifying. If these two are the same and my stock consists of only E, automatically my string is accept. If it is not in the sense, with the help of my flag value. If the flag value does not turn, that means it must be the error. So that's why I'm verifying. If flag equal to 0, it must be the error. So this is the program for the shift reduce parser. So now we are going to be execute once. After that, if you have any doubts, feel free to make a call. So now so this is our program, the same program what I show you on slides, the same program. So the program can be stored under a desktop part. So first I want to move to the desktop and I want to verify. Yes, my program name is sr.c. So first I am going to be remove my a.dot file. So first I want to be compiled this cc sr.c. Okay. So now I want to be check it. Sorry, ls the same. I am getting a dot out. So now I am running a dot out. Okay, it asking it. Enter the input symbol. So if my input symbol is A plus B by B star, clearly observe. What are the terminals it is going to be accept? Either A or B or plus by star. So A must be accept plus also B also by also B star A. Okay, must be accept. Now observe. Now once again I am going to be run. This is my grammar. If I am checking A minus B. Okay. So A is minus, there is no minus. It must be reset for the minus. Clearly observe. When it reads the minus, it must be gives the reset. So we want to be check it once again, one more. Still now we are considering A and B. So if you are taking A minus C, like A only accepted, for minus C can gives the error, and you can observe the one more like A plus C. So A and plus C is the valid terminals for us. A and plus are valid terminals for us. We want to be checked for this. Okay, must have the reset. So I hope all you are understand this program, and now try to execute this program in your systems. If you have any doubt while executing your program or running your program, make a call me and clarify your doubts. Okay, thank you.